In the previous video, we discussed Cramer's method for solving systems of linear equations, and I gave you a homework problem at the end of the video that we are going to solve today. Now you can see that this system of equations contains three variables, x, y, and z, and before we can start solving using Cramer's method, we need to rearrange the variables so that they can be put into a matrix. Otherwise, the solution will not be correct. We need to make sure that every variable corresponds to its own column. So let's do that. And let's say we have our primary matrix. And in the first equation, x is 1, y is 2, and z is 1. In the second equation, x is 3, y is -1, and z is -1. And lastly, x is -2, z is 3, and y is 2. So this is a matrix we can work with. So let's find the primary determinant, which is the determinant for this primary matrix. And we'll do it over here. Our primary determinant will be the determinant of the third order. And before we calculate it, let's use one of the properties of the determinant that we can add rows or columns together to modify either a row or a column. And in this case, we will change the second row of our primary matrix. And we will do so by adding the first row to the second row. And this will not change the first row, but the second row is now going to look like this. So it's 4, 1, and 0. The third row remains the same, so it's -2, 2, and 3. Now our calculation is greatly simplified since we only have to calculate two coefficients. And let's proceed to calculate our determinant, which is going to be 1 multiplied by 4, 1, -2, and 2, plus 0, and plus our third term, which is 3, multiplied by second order determinant of 1, 2, 4, and 1. So what does that give us? 8 plus 2 is 10, and we have 10, 1 minus 6 is -5. Wait, it's 1 minus 8 is -7, times 3 is -21, so 10 minus 21 is -11. We have our primary determinant. We know that it's not 0, so it has a unique solution. Now let's go ahead and find our determinant for x first. So we have our original matrix, and now we substitute the first column with the values we had over here. So -1, -1 and 5, and the rest stays the same. So of course we will factor out -1 from the second row. So we have -1 multiplied by our determinant, 1, 1, 1, and guess which row we're going to use to calculate it. Yep, we are going to use the second row. So the first term, according to our matrix of symbols, is going to be negative. So it's -1 that we factored out, multiplied by our determinant that starts with -1, multiplied by the determinant of the second order, or the coefficient of this term, 2, 1, 2, 3. And then the second term is positive, so it's plus 1 multiplied by -1, 1, 5, and 3. And the last term is negative, and we multiply 1 by -1, 2, 5, and 2. And that's our determinant now. If we calculate that, we get -1 multiplied by, so the first term is 6 minus 2, 4, so -4. -3 minus 5 is -8, so -8. And -2 minus 10 is -12. However, it's multiplied by -1, so that's just plus 12. So it's positive. So -12 plus 12 is 0. And there we have it. So do not freak out. In this case, we can have a 0 in the determinant, so that just means that our x is going to be 0. Now let's calculate the determinant for y. If we substitute into the original matrix, so it's 1, 3, -2, and we have -1, -1, 5, and we have 1, -1, and 3. So let's see what we can do here. And right off the bat, I think we should again add our first row to the second row, which should give us 1, -1, and 1. 4, -2, 0. Yep, funny number. -2, 5, 3. So that was not planned. Now we can calculate the determinant, and that equals to, we'll use, of course, the third column. So we have 1 multiplied by the determinant of 4, -2, -2, and 5, minus 0 plus 3 multiplied by 1, -1, 4, and -2. Now let's calculate that. We have 20 minus 4, so that's 16, plus -2 plus 4, so that's 2 times 3 is 6. And that equals 22. Lastly, we calculate the determinant for z. And we have the same in the first column. We have 2, -1, and 2 in the second column. And we substitute the third column, -1, -1, and 5. All right, so let's use, I'm thinking we could use the first row, whatever, why not? So we have 1 multiplied by -1, -1, 2, and 5. minus 2 multiplied by 3, -1, -2, and 5, and plus -1 multiplied by 3, -1, -3, -1, -2, and 2. Yep, that's correct. Let's calculate. So we have -5 plus 2 is -3, minus 15 minus 2 is 13, multiplied by 2 is 26, minus 26, plus 6 minus 2 is 4, so we have 4 multiplied by -1 is -4, so it's actually minus 4. And that gives us -29, -33. All right, so let's calculate our variables. Now I will rewrite below. So we have our main determinant, primary determinant equals to -11. Our determinant for x that equals to 0, determinant for y that equals 22, and our determinant for z equals -33. Well, it divides very nicely, and we're going to get our whole numbers. So starting with x, it equals obviously to 0. Our y equals 22 over -11, or -2. And lastly, our z equals to -33 over -11, or 3. There you have it. We just found 3 variables without substituting anything, just using the good old Cramer method. Thank you for watching. Don't forget to like and subscribe, and stay tuned for more math videos. Bye-bye.